Let's take a look at finding angular displacement. Angular displacement is delta theta, okay? It's how far we've moved. So starting from here, going around the unit circle, how far did we go, okay? What is our value that we went? And the way that we do this, so if we take a look and say we went this far, some value theta. Okay, so our change in theta, in this case, we started here, ended up there. That is our angle in radians that we went. And what it's going to be is this change in arc length. Okay, so that's this change right here on this part of the arc right here, divided by the radians. Okay, or I'm sorry, divided by the distance from the axis. Okay, so our distance from the axis started here to here. This is our distance. So let's take a look how it changes if I come out here. If I increase that distance from the axis, it makes our arc much bigger. So as this went up, this had to go up as well to keep our same angle measure. So to solve angular displacement, we're just going to take this change in arc length, whatever this distance is, and we're going to divide it by the distance from the axis. Distance from here, or the radius, is what we're going to do. Alright, angular speed now. In angular speed, what we're going to do is we're going to take our angular displacement, and that angular displacement is what we solve for up here. So we're going to take this angular displacement value, okay, or it may be given to you, and how long did it take for that to happen? Remember in speed, when we talked linear speed, like miles per hour, meters per second, it's some distance over time, and that's kind of what we're getting here, is a distance over time, except now we're doing it around a circle instead of going straight forward. So to find our angular speed, we're just going to take this value that we looked at for theta, or change in theta, or change in arc length, what that distance is over time, and that's going to give us our angular displacement. And the last thing we're going to talk about is angular acceleration. Angular acceleration now is going to be our value. We just found our speed value, okay? So we're going to take our change in angular speed, and we're going to divide it by how long did that take, the time interval. So we'd take a speed 2, or a final speed, and subtract our initial speed, and that's going to give us our change in angular speed. And we're going to divide it by our final time minus our initial time. And a lot of times this is 0, so you can just say it happened in 3 seconds. Well, that would be 3 minus 0, or 3 seconds, okay? But this helps if we say what was the average angular acceleration from 3 to 5 seconds. Well, then we'd put 5 here and 3 here, and we know it's a 2-second change in time. So these are the equations that we're going to need to be able to solve problems for angular displacement, angular speed, and angular acceleration.